All right, in order to solve quadratic equations, one of the primary methods we're going to use to do that is going to be by factoring. So we need to remember our factoring polynomials from grade 10. So we can factor by taking out a common factor, which should always be our first step if possible. We can factor by difference of squares. We can factor by inspection. We can factor by decomposition and grouping, which we're going to focus more on in the next lesson. So, to begin, Joe correctly writes the quadratic expression x squared minus 8x plus 12 in factored form as x minus 6 and x minus 2 using the inspection method. So how does this work? We need two numbers that add up to -8, or the coefficient of x, not x squared, and also multiply to 12, or the constant. Those are my two factored numbers. So in this case, I have the x squared minus 8x plus 12. The two numbers that add up to -8 but multiply to 12 are -6 and -2. So I just rewrite it as x minus 6 and x minus 2. So if I am factoring the following by inspection, I need two numbers that multiply to make 30 but add up to 13. And the two numbers are going to be 10 and 3. So I would say that this equals x plus 10 and x plus 3. For the second set, I need two numbers that multiply to -30, which means one's positive and one's negative, but add up to -13, and my two numbers are -15 and positive 2. X minus 15, x plus 2. And for the last one, they need to multiply to make positive 30, but add up to -11, which means that both numbers have to be negative to multiply to a positive, but add up to a negative. And they are -5, -6, so x minus 5 and x minus 6. If I'm factoring ax squared plus bx plus c, where b is equal to 0, or I'm missing that middle term, then if I'm factoring the quadratic expression x squared minus 16 using inspection, well, I need two numbers that multiply to -16 but add up to 0. Which means that they're going to be equivalent numbers, one's positive, one's negative. Well, the two numbers are going to be positive 4 and negative 4. If I'm stating three other values for c, which the quadratic expression x squared minus c can be factored over integers, then I'm just looking for other possibilities where it's going to be a positive and negative of the same number. So if I said it was positive 5 and negative 5, then c would equal -25. Or positive 25 in this case, because it says minus c. If I said that it was positive 2 and negative 2, then it's going to be 4. If I said it was positive 3 and negative 3, it's going to be 9. So any perfect square will work. Why do we call this a difference of squares? Difference in math means subtract. and the term squares is referring to perfect squares. So as long as I have two perfect squares subtracted from each other, then it is always going to be a factoring by difference of squares. So if I'm using the difference of squares methods to factor these, well, the square root of x is just x. The square root of 49 is going to be 7, so it would be x plus 7 and x minus 7. In the second case, square root of t squared is just t, and the square root of 64 is 8, t plus 8, t minus 8. Here, if I have 25x squared, the square root of that is going to be 5x. Square root of 1 is just 1, so 5x plus 1 and 5x minus 1. And in the last case, the square root of 100x squared is going to be 10x. Square root of 81 is 9, so I get 10x plus 9 and 10x minus 9. If I'm removing a common factor, then all I'm doing is I'm saying that I can divide all three terms by the same value. Or in this case, I actually just have two terms, 2x squared minus 50. So in this case, I'm going to divide both of them by 2. And I get that 2 and x squared minus 25. Well, now I can see that the x squared minus 25 is going to be a difference of squares, so I leave the 2 on the outside, and then I square root it, x plus 5 and x minus 5. So that's why I said in any case that we have, always try and take out a common factor if it is all possible. It is much easier to factor down with the smallest numbers possible. So we're going to do that for example 3. Step 1 is we're going to pull out the common factor. Well, I can divide both these by 5, and then I am left with x squared minus 4. And then I can see here I have a difference of squares. So I'm going to factor that further and say that I have 5 and then x plus 2 and x minus 2. For the example directly below it, I can divide both those by 16, and I'm left with x squared minus 4 again, or 16, x plus 2, x minus 2. For the ones on the right, I can divide all these terms by 2, and I'm left with x squared plus 8x plus 15. Well, two numbers that have a product or multiply to make 15 but add up to 8 are going to be 3 and 5. 2, x plus 3, and x plus 5. For example D, I'm going to divide that negative 3 out of all of it, and I'm going to get x squared. Because I'm dividing by a negative, I don't just divide the 3 out, but I have to change the sign, so 6 divided by negative 3 is going to be negative 2x and negative 3. And then two numbers that multiply together to make negative 3 but add up to negative 2 are going to be positive 1 and negative 3. Now, when we're talking about common factors, it doesn't just have to be a set number. Common factors can be variables, or they can even be binomials, as long as it's being multiplied into all of the different terms. So we can see here we have 3x and x minus 9, and 2 and x minus 9. The two terms are split up always by either a plus or a minus. So I can say this would be one term, this would be another term. Both the terms have an x minus 9, so I'm going to pull out the common factor of x minus 9, and then just like I would if it was just a set integer I'm dividing out, then I would group together what is left on the outside, the 3x and the negative 2. I can do the same thing here. They're both being multiplied by 2x plus 1. And then I'm going to group together what is outside the brackets, the 5x and positive 7. Down here, I have the 2x plus 1. And then I can group together the 9x. And if it doesn't write anything, I know there's always an imaginary 1 beside the coefficient, so plus 1. And in the last case, I have a common factor of 3 minus 2x. And then I have the 8 and positive x. When I'm factoring by grouping, all that I'm doing is I'm taking 4 separate terms, grouping the first set and the second set together, or an x squared with an x and an x with a constant, and then pulling out the common factor to make it look like the examples that we just did. So when I am factoring it out and I pull the common factor out of them, in this case I can pull an x out and be left with x plus 4, and on the right hand side they're both divisible by positive 6, and I'm left with x plus 4. I know that I've done it correctly as long as what's left in the brackets is identical. So that is the common factor that I can pull out. And I'm going to say that this is going to be x plus 4, what's in the brackets, times x plus 6, what's outside the brackets. In the second example, I group them together, and in the first set I can pull out both 2, and they both have an x. And then I'm left with x minus 4. In the second set, I can divide them both by positive 3, and I'm left with a x minus 4. Take what is the same in both brackets, and I'm going to divide that out, x minus 4, and then group together what's outside the brackets, 2x plus 3. For example C, I can divide both these by 4a, and I'm left with 2a minus 1. In the second set, there doesn't appear to be a common factor, so I can just say that the common factor, the thing I can divide everything by, is 1, and 2a minus 1. And I can still see that I have the common binomial factor of 2a minus 1 that I can pull out. So I got 2a minus 1 and 4a plus 1. When I get to example D, then for example D, I'm going to do the same thing. I'm going to group them together, and when I divide out the 3x from the first set, I'm left with 2x minus 3. In the second set, the common factor is 2, and that would leave me with negative 2x plus 3. But then I can see that these two are not identical. So if the signs inside are wrong, then that means I need to change the signs by taking out a negative. So I'm not just going to divide by 2, I'm going to divide by negative 2. And then it's going to flip the signs, 2x minus 3, and now they match. 2x minus 3 and 3x minus 2. Same thing with the last example. For example E, I'm going to divide 8x out of the first two, and I get 2x minus 1. And in the second set, because the sign for x is wrong, I want x to be a positive, I'm going to take out a negative. There is no common factor, so I'm going to say it's negative 1 and 2x minus 1. And group them together. 2x minus 1 and 8x minus 1. And that's it.